Hey guys, so today I'll be showing you how we can code a Python script that can automatically feed the kids. So what it's going to be doing is it's going to be using the OpenCV library, and it's going to take a screenshot of this here, and it's going to pretty much reverse search this word and see if it matches up with anything. It's mostly accurate. Sometimes, like for the dictionary we're using, sometimes the word can't be found, so we added a system where it will just choose randomly. So first thing we're going to have to download is this tesseract. You would probably want to choose which one would fit you best. 64-bit you'd go here, 32 here, and that's pretty much for actually downloading stuff from Google. You'd pretty much run the installer and set it up how you want it. So here in our Python window, we're going to have quite a bit of things to install. So these are all the things you'd want to pip install. We have OpenCV, so this will be our image recognition. PyScreenshot will be to actually take the screenshot. PyTesseract or whatever to actually read the image, and then we have PyDictionary, which is our dictionary to see what that word means, and then we have PyAutoGUI, which pretty much just moves the mouse to the right thing, right? So here are the imports we will be using. Pretty much everything is the same. It's just going to be time and random, so we can have just random times. Or no, time will be, it's like we have to let it load, because when we go here, right? When we go here, we can close that off. If I do effect means like woods, right? There's like a delay, right? Like 1, 2, 3, and then it actually shows up. So that's pretty much it. And random we're using if the word doesn't exist in the dictionary, then we just pick a random word. So when we're doing this on my screen here, we're going to want to zoom in 250%. So it's like this, right? The reason for this is when we take a screenshot, right, with snipping tool here, I'll show you here, we have all the letters are nice and big, right? The computer can see this is glad, means, and then we have what each word means, right? However, when we zoom all the way back to 100, and the computer takes a screenshot like this, let's zoom in, you can see how it becomes a bit hard, right? It'll have some trouble reading wealthy, maybe terrific somewhere, and it's not accurate, right? So it's better to have it nice and big. So what we're going to first start off with is we're just going to want to add a comment here to have it zoomed in 250%, right? So what we're going to want to do is we're going to want to do dictionary will be equal to PyDictionary. We're going to add that. Just initialize it. And then this is where the PyTesseract part comes in. So we're going to do PyTesseract dot Tesseract CMD will be equal to R, and then we're going to put our file path that we installed it to. So I saved it locally onto my account. So this is how it looks like. It might be different for yours, but just find the file path of this executable. And all the download links for like PyTesseract and everything, and all the pip installs, I'll have those in the description. So then once we go here, it's just going to be like a while true loop, because we want it to run indefinitely until we just move the mouse to the top corner, or we just move it into our console and we stop the program. So we're going to just do while true, add that semicolon. So now we're going to do im will be equal dot image grab dot grab. So this will actually be taking the screenshot. So this will be box will be equal. This might be different for each of your screen sizes, because I'm on the 2560 by 1080, so like an ultra wide, right? So my 250% zoom in might be a bit different, but essentially you want to treat your screenshot as something like this, right? You want it to look here and get that. You don't really want, you want it nice and big. So we can just close that off. You want it something like that. So for me, what numbers I went with are 870, 200, and then 16700, and then 1000. And if you're wondering how these are in the order of, let me copy paste this here and this here. It's like this, right? So this will be x1, y1, and then x2, y2, pretty much. Next, we're going to just save this image. This pretty much just allows it to just save it, and then we reopen it. We don't want any like issues. So I'm just going to do image.jpg. JPG is just a much lighter weight than PNG, so it'll take up less space. So then here we're just going to do image will be equal to cv2 dot image read, and here we're going to be opening up the image with cv2. So this is going to be image dot jpg. So now we're opening up the image, and we want to go here, and we want to get text from image. And what this is going to be, just text will be equal to pytestrect dot image to string and image. That's pretty much it. And then we're just going to want to print our text. And then we can just do input and then just whatever. So we can just pause it. So I'll just drag this onto my second monitor here, and we see we have this over here. And when I run the script here, right? I'll minimize here and I'll show you again. What we get in our console is we get three things. We get glad, means, wealthy, terrific, big, and happy. And probably just something extra here. We can probably, oh yeah, it's just the input here. So we can close that. So that's good. That's how we know it works, when it prints everything here. We can even see here, glad, wealthy, terrific, awesome, all right? So what we're going to do is these will be our options, and this will be our word we have to find, glad. And we know that we can work backwards here with Python. We know that we will always get rid of these strings here. We don't want to guess from the front, we want to get rid from the back. And we will always get the word. And that's pretty much what we do. And then we're going to split these strings here. So wherever there's a new line, we're just going to split it, and this will be its own part in a list, its own indice or indice in a list. So what we're going to do next, let's just minimize the console here. We're going to go to, we're just going to break down the spaced out words. And the way we're going to do this is just possible. And this will be, let's go with options, will be equal to a list. We're going to put these brackets here. And we're going to filter it for none. And then it's going to be text dot split. And we're going to go here, dash n, so for a new line. And then we're going to go out here, go to semicolon, -1. We're going to have these two brackets, and then go here, and then one double colon. So this will pretty much just get everything, get all of our possible options, right? So if we just print possible options, I'll just drag this here. Probably can't see, but you can see this giant tab here. And I will run my script here. Well, let me just add a little input here so you guys can see input and just do a pause. So when I run this script, let me show you guys, you can see that we get every word in a list here. We get wealthy, terrific, big, and happy, and that's exactly what we need. And if this works, that means we can get the glad, and it's easy it's really easy. It's just simple, I guess, logic in a way, right? So now we just want to do our word to search, and this will be equal to a list. I'm going to go here, and I'm going to do filter. I'm going to do none again, comma, text dot split dash n, and then we're going to go here again. Go here with -1, We're going to go here with 0, and then we're going to be removing the last 7 digits. We're going to go here, -7. And that's pretty much it. Then we're just going to do possible meanings will be equal to dictionary dot synonym, right? Because when we all of the answer for all of these are actually synonyms. So for example, glad, a synonym for glad is happy, right? That's the cool thing about this, right? So afraid, a synonym for afraid is scared. So that's how we're going to be basing our thing, right? So we're just going to use this dictionary, and we're going to search in it for our word to search. That's pretty much everything, and I'm just going to copy over this little print statement we have here. It's a little handy dandy one. So that's just going to do, word, oh, I didn't, there you go. And that's pretty much it, right? So when we do this, it'll just print the word we have to search, the possible options we have, and then the possible meanings. Let's do meanings actually, because we can actually have multiple. Awesome. So now that we have this done, we can just do checking against our dictionary, right? But we first want to check if the word exists, because sometimes in our dictionary the word doesn't exist, and I'm working on a cool little dictionary thing here that should have all of these words. So for example, if the way we would do this is word found is equal to false, right? We're going to add a boolean or a true false statement here. So then we're going to do if possible meanings equals none, right? If there's nothing inside, then we're going to do possible meanings will just be equal to, I don't know, a random string, right? It doesn't have to be anything. Usually the small, like T works, it can be anything. So now we're going to do for I in range, and then we're going to put these brackets, length of possible options. We're going to add this semicolon here. And we're going to do for j in range, and then length of possible meanings, put that here, and then if possible options I is equal to possible meanings j, then we're going to do so just to be a simple thing, position will be equal to I plus 1, and then word found equals false. So this will just pretty much be a check found. Oh. So this is just checking if the word, if this, like for example, when we have a list, right? Let's go here. We have these lists here, right? So we have apples and bananas, right? And we have apples. Oh, I cancel apples, right? It's going to check if apples is in here. However, if we have this word and it's not here, it will return, it will stay false. Oh, that's supposed to be true. Gotta make sure we change that. There. So our next thing we will be doing is pretty much just checking the position, just actually moving the mouse and clicking in the right spot. Okay, so we're around 15 minutes. We should be done in like 3 minutes. So pretty much what we're going to do now is if not word found. So this is pretty much saying if the word isn't found, we're just going to do position. Oh, no. Position. Position will be equal to a random rand int from 1 to 4. So what this pretty much will do is if the word isn't found, it's just going to pick a random a random one, right? We don't want it to hang and just freeze. We just want it to pick a random one and keep going. It's much more efficient, and it doesn't end up flagging any, I guess, anti-bot measures. Like, you can't use Selenium or any automated browser because they block it right away, but like, there's no way for them to know that it's not automated, right? Because it's like grade 1, like, create, come on, man, like, how are you gonna know a computer did it? So what we're gonna back on to track here, we're just going to do checking what box to click, and pretty much it's going to be if position is equal to 1, go here, and this will be, we're going to use pi auto, so pi auto dot move to, and then we're just going to do the coordinates, so 950, 450. So on my computer, 950 is around here, and 450, and it's just going to keep cycling down. And then we're going to go here, and then we're just going to get it to click. Pi auto GUI dot click. Add that here. That's pretty much it. We're just going to copy paste this 4 times. We're going to go here, 1, 2 of them, and that's 4 of them. So now we're just going to go change this to 2, 3, and then to 4. And then over here, we're going to keep it 950 because we want it to stay in this same row here, right? We don't want it to shift over. There's no point. But we're just going to change how low. So this will be 600. So I believe it goes up by 150 every time. So yeah. So this will be 750, and then this will be 900. And then pretty much you just want it to give it some time to actually load up the new one. So this will just be time.sleep.4. And then we can just, I don't know, print done, whatever. Right? So now what we can do is we can drag this over here, plop up this tab, so hopefully you guys can see, right? And I'm just going to rerun this tab, and you can see, oh, hopefully it's running. No. Oh, hold on. Okay, let me rerun this here. Okay, oh, it's asking if I want to stop and rerun. Fantastic. So now you can see that it will automatically move, right? Like, I can clap for you right here, right? And you can see that here it couldn't find the word, but it picked something random, right? So I'm clapping. You can hear that, like, you know, it's not me clicking the mouse or anything, right? So I'll just quickly stop this, and I can show you the console log here, right? And we can see that, like, we can see listen, and we have all of these here, and we have up here, make better, here, shout, and we can see here came up here, so it chose that option, right? And it would have chose option 3. So hopefully this helps you out. It's quite a cool project, and I think it's a pretty cool start into, like, maybe image recognition, and it helps out quite a lot of kids. So hopefully you enjoyed, and if you couldn't catch any of the links, I'm going to have all of those in the description, and feed some kids.